The real-world figures that logistics companies rarely disclose to the public reveal a surprising truth. Why more and more transportation giants are willing to stake billions of dollars and their entire business future on the Tesla Semi. How is the Tesla Semi establishing an absolute competitive advantage over diesel trucks on steep mountain passes? The astonishing consistency and economic efficiency among the aforementioned enterprises stems from foundational upgrades, which have taken many drivers by surprise during their initial operations of the Tesla Semi. The difference lies not merely in rapid acceleration or immense tractive force, but in how the vehicle handles grueling extended mountain passes. This is not an emotional perception or transient excitement over a novel technology. It is a tangible, measurable reality experienced after years of working with traditional diesel trucks. The most prominent advantage emerges when the Tesla Semi descends complex mountainous terrain. During downhills, the electric motors cease consuming energy to generate forward thrust, shifting instead into generator mode. The colossal kinetic energy from a tens of tons payload surging downhill is converted into electricity and fed back into the battery pack via the regenerative braking system. This mechanism yields three simultaneous benefits that diesel trucks can never achieve due to the physical limitations of the internal combustion engine. First, the mechanical braking system remains virtually idle throughout the descent, as the retarding force from the electric motors is sufficient to modulate vehicle speed smoothly. Second, heat accumulation on the brake pads and rotors is drastically mitigated, thereby completely eliminating brake fade caused by overheating, the leading cause of catastrophic accidents on mountain roads. Third, rather than wasting energy as heat and the roaring noise of exhaust engine brakes, the Tesla Semi captures 80% to 90% of this kinetic energy, storing it in the battery for subsequent segments of the journey. For a diesel truck, every descent translates to component wear, heightened safety risks, and escalating maintenance expenses. Conversely, for the Tesla Semi, each downhill run becomes an opportunity to recoup free energy and extend driving range. The clearest testament comes from real-world testing at Donner Pass in the Sierra Nevada, one of the most treacherous routes in the United States with gradients reaching 6%, while diesel trucks must laboriously ride their brakes and crawl downhill at a snail's pace. The Tesla Semi maintains a steady speed aligned with traffic limits without the driver ever touching the mechanical brake pedal, while simultaneously pumping dozens of kilowatt-hours of electricity back into the battery pack. On the exact same route, the economic outcomes and safety margins between these two generational technologies have become completely polarized. Crucially, this technology cannot simply be retrofitted onto diesel vehicles via upgrade packages or aftermarket accessories. Regenerative braking is a structural characteristic inherent to pure electric powertrains. Although manufacturers have experimented with energy recovery systems on hybrid vehicles, the efficiency achieved remains a fraction of that of a pure electric vehicle due to limited battery capacity and overly complex mechanical architecture. In hybrid systems, conventional mechanical brakes must still shoulder the bulk of deceleration, continuing to dissipate energy as wasted heat. This represents a technological threshold that the internal combustion engine can scarcely cross through incremental improvements alone. Is real-world data from logistics conglomerates validating the superior economic efficiency of this vehicle line? The positive outcomes derived from the empirical data of leading logistics conglomerates prove that these benefits have completely moved past theoretical laboratory claims. Since Tesla officially commenced volume production at Gigafactory Nevada on April 29, 2026, these large-scale real-world evaluation programs have been established to justify multi-million-dollar investment decisions. Independent verification data from the North American Council for Freight Efficiency, NACFE Run on Less program provided the most objective perspective, as Tesla Semi-units within PepsiCo's fleet demonstrated rigorous endurance by traveling continuously over 410 miles, approximately 660 kilometers on a single charge under fully loaded conditions. Furthermore, one vehicle in the test cohort completed a total of 1,050 miles within a 24-hour window by capitalizing on fast-charging windows between shifts, thoroughly dispelling skepticism regarding the viability of electric trucks for long-haul operations. Reflecting on the data table, ArcBest recorded an average energy consumption of approximately 1.55 kWh per mile after a 3-week trial across highly diverse and complex terrains, a figure that not only aligns with the optimal technical specifications published by Tesla, but also proved more stable than the initial forecasts made by ArcBest's own engineering team. Meanwhile, DHL Supply Chain achieved a consumption rate of around 1.72 kWh per mile, even when operating continuously at maximum payload capacity. Following this rigorous evaluation phase, DHL formally integrated the vehicles into large-scale commercial operations. The economic advantage becomes even more compelling when converted into direct energy costs. At an average consumption of 1.6 kWh per mile and under average U.S. commercial electricity rates, the energy cost of the Tesla Semi fluctuates between a mere 0.15 and 0.20 USD per mile, compared to a conventional diesel truck operating at an efficiency of roughly 6.5 miles per gallon, which translates to a fuel cost of approximately 0.50 to 0.60 USD per mile. The Tesla Semi slashes direct energy expenditures by over 60% per mile of travel. Parallel to the economic calculus, environmental objectives are being materialized through quantifiable metrics, such as SA Logistics reducing approximately 4.38 tons of CO2 during a brief pilot program, for enterprises like MDB Transportation and AIO Logistics. 3-week trials on port drayage routes characterized by continuous stop-and-go frequency transformed congested urban zones into ideal environments for the regenerative braking system to maximize its utility. The fact that multiple distinct enterprises, operating on isolated routes under completely disparate conditions, yielded uniformly positive results serves as definitive proof that the Tesla Semi's advantage is a sustainable, systemic superiority. Where does the core bottleneck lie today when infrastructure constraints and supply chain pressures persist? Despite evaluations universally logging exceptional efficiency, the wholesale transition of enterprise fleets cannot materialize overnight. The root cause of this delay lies entirely outside the operational capabilities of the vehicle itself, tracing instead to charging infrastructure and production supply constraints. The operational model of Covenant Logistics serves as a prime case study illustrating the line between ideal scenarios and practical execution. The 200-mile daily route utilized by Covenant during its trial represents a flawless environment for an electric truck, where the vehicle departs from the depot in the morning, completes its daily run, and returns for overnight charging. With a fixed 125 kilowatts charger requiring an initial capital expenditure of approximately $20,000, this closed-loop model is entirely viable without relying on external public charging networks. However, major logistics corporations generally operate sprawling, interconnected interstate transport networks that demand extreme flexibility. For long-haul segments that exceed the 500-mile single-charge threshold, the current density of the megacharger network remains insufficient to support such demands. Constructing megacharger stations utilizing the Megawatt Charging System (MCS) standard demands a power grid capacity of 1 to 3 megawatts per charging stall, equivalent to the electrical demand of a small industrial factory, requiring enterprises and Tesla to collaborate closely with local utility providers to upgrade substation infrastructure, a process that typically takes several months to years to clear regulatory and construction hurdles. Compounding the infrastructure barrier, Tesla's manufacturing capacity is under severe strain against overwhelming market demand. The specialized Tesla Semi facility in Nevada is designed to target a peak capacity of roughly 50,000 vehicles annually when fully built out. However, actual production volume for 2026 is projected to hover between 5,000 and 15,000 units, representing a mere 10% to 30% of design capacity due to supply chain constraints surrounding large-format 4,680 battery cells and high-power semiconductor components. While supply trickles in, the order pipeline from corporate giants continues to lengthen. PepsiCo, DHL, and particularly Watt EV with its massive order of 370 units, the largest publicly confirmed order in the industry to date, are creating a severe supply deficit. This stark discrepancy between market demand and actual supply capacity poses a formidable challenge for Tesla, forcing them to accelerate production line scaling within the next 18 to 24 months if they intend to sustain the momentum of interest and technological migration surging from the transport sector. Will the transition become an absolute inevitability once the cost equation is completely solved? For decades, the diesel trucking industry incrementally refined its powertrains through variable geometry, turbocharging, high-pressure common rail fuel injection systems, and optimized combustion chemistry. However, all of these mechanical refinements were merely marginal advances, optimizing a technology that had reached its physical limits, completely failing to address the core deficiencies encountered on complex mountainous terrains. Severe brake system overheating, torque loss on steep inclines, and the massive waste of energy via thermal dissipation remain unsolvable equations for the internal combustion engine. Because the structural, physical advantages of electric motors cannot be replicated or reversed, mountainous freight routes will inevitably become the first areas where diesel trucks are displaced and entirely lose market share. These are the exact corridors where brake maintenance costs peak, safety risks run highest, and per-mile operational expenditures for diesel vehicles are driven to their absolute maximum. What is the real-world vision when electric vehicle savings transcend mere technology pilots to become a financial survival tool for logistics enterprises in the new era? Covenant Logistics is not a technology firm, and its executive leadership possesses no financial incentive to provide free publicity for Tesla. On the contrary, during the first quarter of 2026, under the pressure of macroeconomic headwinds and cost-cutting directives, this company aggressively liquidated 422 legacy diesel trucks while adding a meager 53 new units in an effort to downsize their fleet, tighten expenditures, and shore up their balance sheet. It was precisely within this climate of rigorous, penny-by-penny austerity that Covenant chose to dedicate 3 weeks to putting the Tesla Semi through a strict evaluation protocol, proving that the operational savings generated by electric trucking are sufficiently substantial and impactful that chief financial officers can no longer afford to ignore them. When fleet managers professionals who look exclusively at data and scrutinize every fraction of a cent per mile pivot from skepticism to discussing operational confidence, it signals that the market's tipping point is imminent. The simultaneous wave of successful trials across a multitude of major logistics enterprises is no longer a localized media phenomenon. It is the clarion call signaling that the global road freight industry is entering an irreversible paradigm shift. Do you believe Tesla's Semi will change the future of freight transportation? Let us know your thoughts in the comments below. If there is just one small thing you could do to support this channel today, it's hitting that subscribe button. It costs nothing, but it means the world to us. Thanks for watching. See you in the next episodes.